Okay, this is Module 7 study guide. So the first question is to fill in the blanks to complete the proof for the triangle sum theorem. So what we're doing is we're actually proving why a triangle has 180 degrees when you add the three angles together. So we're given triangle ABC, pictured here. Prove that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. These are the interior angles here. When we add the 3, it equals 180. But this is why. So draw a line L through point B parallel to AC. So this line up here is parallel to AC at the bottom. So if you guys remember from a previous chapter, we had two parallel lines cut by a transversal and alternate interior angles were congruent, same side interior angles were supplementary. So if you notice that pattern here, these two parallel lines, this is our transversal. We're creating those alternate interior angles. So angle 4 and angle 1 are going to be equal to each other because they're congruent. And similarly, because these lines are parallel, we can create another transversal here, BC, if we extend it. And 3 and 5 will also be alternate interior angles as well. So the measure of angle 3 is going to be equal to the measure of angle 5. And this is because alternate interior angles are congruent. Alternate interior angles are, and I'll put my little congruent symbol. So, on statement 3, measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 equals 180. We're referring to these angles above that are forming this straight line. So 4, 2, and 5 added together equals 180. Angle addition postulate is we're adding the three angles together and it's forming this straight angle. So remember, a straight angle is 180 degrees. But if you recall, we said that angle 1 and angle 4 are equal to each other, and angle 3 and angle 5 are equal to each other. So if we can substitute the measure of angle 1 with the measure of angle 4. So wherever you see the measure of angle 4, that can be replaced or substituted with the measure of angle 1. Similarly, the measure of angle 5 from above, we know is equal to the measure of angle 3. So we can substitute in the measure of angle 3 in for 5. So with that substitution, what we end up doing is showing that angle 1 plus angle 2 plus angle 3 equals 180 degrees, which is what we wanted to prove. But how did we do that? We conducted a substitution, a replacement. So substitution property. Okay, so number 2, find the measure of angle B. So here we have this figure. The main idea behind this is for you guys to see that the remote angles, remote just means further away. So the angles that are furthest away from the exterior angle are congruent to the exterior angle. So that would be angle A, and angle B out here would be congruent to the angle that's on the exterior. So angle ACD. That's the main idea. So we're just doing a practice question and applying this idea to this figure here. So our goal is to find the measure of angle B. So what we have here is 145 on the exterior, angle A and angle B. So let's set this up. Angle A plus angle B equals the angle on the exterior, which is, we can call it ACD. the measure. So angle A is 2Z, and angle B is 5Z minus 2, and this is going to equal the exterior angle, the angle on the outside. So if I combine like terms, I end up with 7Z minus 2 equals 145, and I'm going to add 2 to both sides. So we end up with 7Z equals 147. And when we divide to both sides, 147 divided by 7 gives us 21. So Z is 21. But notice, this is Z, but that's not what we were finding. What we're finding is the measure of angle B. So we know that B is 5Z minus 2. Now that we know what Z is, we're going to apply 5 times 21 minus 2 is going to give us the measure of the angle that we're looking for. So 21 times 5 minus 2. So the measure of angle B equals 103 degrees. And that's what we were looking for. For part B, the exterior angle drawn measures 150 degrees, the angle on the outside, and the measure of angle D is twice that of angle E. So that's important. The measure of angle D is twice that of angle E. I need to use that since I don't have any other information on my picture. Find the measure of the two remote interior angles. So after we find what one of them is, we can find the measure of the two that are missing to figure out what angle D and angle E are. So very similar to part A, the main idea is that the remote angles added together are congruent to this exterior angle. And I have this relationship here that angle D is twice that of angle E. So whatever angle E is, I'm going to multiply it by 2, and that's going to tell me what angle D is. So if I write this out, I know that angle D, the measure of angle D plus the measure of angle E equals the measure of the angle on the exterior, measure angle DFG. So angle D, I know, is 2 times angle E. So 2 times angle E plus 1 times the measure of angle E equals 150. Let's just put that in there. So we end up with, okay, well this is twice that of E. So 2 plus 1 gives us 3 angle E measures equals 150. And if we divide by 3, this gives us the measure of angle E. The measure of angle E equals 150 divided by 3, which is 50 degrees. Now that we know what angle E is, we know that angle D is going to be 2 times that. So 2 times 50 is going to tell me what angle D is. 2 times 50, which is 100. So the measure of angle D is 100 degrees. And the measure of angle E is 50. For number 3, part A, solve for y. So what I have here, the information I'm given is telling me that this triangle is equiangular. Equiangular means that the angles are equal. So from that, we can imply that all the sides are also going to be equal. So this is also an equilateral triangle. So what that means, equilateral, means that all the sides are equal. So side AB is going to be equal to side AC, which is equal to BC as well. But we have an equation that we can set up with just side AB and AC And this is going to help us figure out what y is, because that's the question that we're answering. So a way to navigate these fractions is to just get rid of them altogether. What we want to do is find the least common denominator that both of these have in common. So 5 goes into 10, but 10 doesn't go into 5. We can multiply both sides by 10, and this will help us get rid of that fraction. So we end up with a nicer equation. So 10 divided by 10 is 1, and 1 times 3 is 3. So this gives us 3y. Again, 10 divided by 10 is 1, so the 10s are gone. 1 times 3 is 3y. Now 10 times 9 is 90. Now over here, 10 divided by 5 is 2. 2 times 4y. And then 1 times 10 is just 10. So we end up with 3y plus 90 equals 8y minus 10. So we're going to combine like terms, subtract 3y from both sides. We end up with 90 equals 8 minus 3 is 5y minus 10. We got a room here. Let's add 10 to both sides. To get the y by itself, we get 100 equals 5y. Divide by 5, y equals 20. So we were solving for y here, but the main idea was actually applying the fact that an equilateral triangle, that means all the sides are equal. So if all the sides are equal and I have these equations, I can figure out what the value of y is. The geometry is this fact up here, setting them equal to each other, and then the rest is just algebra. Okay, for part B here, it's a little hard to see, but this is an isosceles triangle. An isosceles triangle means at least two sides of the triangle are congruent, which means that DF and FE are the same. An isosceles triangle, on an isosceles triangle, the base angles are always congruent because of these sides. These sides are the same. So my base is going to be this DE down here, and my base angles are angle D and angle E. That's the main idea. When these two sides are the same, I know that angle D and angle E, my base angles, are also going to be equal to each other. So using that fact, that's the main idea of this question, is understanding what an isosceles triangle is. Now that we know what angle E is, we can solve for x. Solve for x to figure out what that is. Because we know when we add the three angles together, angle D plus the measure of angle E plus the measure of angle F, it equals 180 degrees. Because it's a triangle. We proved that the triangle sum theorem on question number 1, that when we add the three angles together, it equals 180. So we have 4x plus 1 plus 4x plus 1 plus 5x minus 4 equals 180. Now we're going to combine like terms. So 4x plus 5x, 8 plus 5 is 13. And then we have 1 plus 1 minus 4. So we get 2 minus 4, which is minus 2, equals 180. We'll add 2 to both sides. We get 13x equals 182, and then divide by 13. 182 divided by is 14. So x is 14 here. So here, using the fact that it's an isosceles triangle, we can fill out this angle E information, which then helps us to solve for what x is. So once we know what angle E is, we can use the three angles added together equals 180, and then solve using algebra. Okay, for problem number 4, determine if a triangle can be formed with the given sides. Explain your reasoning. So on this first one, we have 12 units, 4 units, and 17 units. In order to check if we can form a triangle, we need to make sure that all the sides work out. So if we add the first two side measurements together, this needs to be larger than the third side in order to create a triangle. Otherwise, even if we cut out the units and try to put a triangle together, we wouldn't be able to. So 12 plus 4 is 16, and 16 is not bigger than 17. And I need the sum of these two sides to be greater in order to create a triangle. So this is not true. Let me put a slash through it. So we cannot create a triangle with the given sides because ... Okay. So I'm going to have you guys do the next one, 24, 8, and 30. So you have to check all the values. So we got lucky on this first one that this one ended up not being true. But if it was true, I would still have to check the other arrangements. 4 and 17 together to make sure that's bigger than 12. And then 12 and 17 together to make sure that's bigger than 4. On number 5 here, for each triangle, order its angle measures from least to greatest. So in this picture here, what we want to look at is we want to look at the smallest side. So if I have 40, 32, and 15, 15 is my smallest side. My smallest angle is going to be opposite of that side. So BC, opposite of BC is angle A. So if this is my smallest side, A is my smallest angle. So angle A is my smallest angle. And then we have the next smallest, which is 32, which is CA. Well, the angle opposite of CA is angle B. So angle B is the next larger angle. Angle A is the smallest, B is the next biggest, and then the last one, it has to be C. Opposite of C is 40, and 40 is the largest. Okay. So I'm going to leave the next question for you guys to do for practice. Problem 6 here, for each triangle, order the side lengths from least to greatest. So very similar to number 5, but now we're looking at the angle measurements. So in order to order the sides from least to greatest, I want to find the smallest angle now. So I have 5 degrees, 15, and 160. Clearly, angle A is the smallest because it's 5 degrees. So the side that's opposite of angle A is angle CB. So CB is going to be my smallest side. The next biggest is 15 degrees, which is angle B. And the side opposite to angle B is side AC, because it's opposite. So AC is the next biggest. And then the last one just has to be AB, because 160 is the largest angle, and the biggest side is AB. Similarly, I'm going to have you guys do the next question as practice.